Hello, I'm Mr. Bob, and welcome to my Geometry Review video series. This video covers Chapter 12, Section 2, titled Translations. By the end of this video, you will have reviewed recent lessons describing translations using vectors. You will review rule writing for translations, rule writing to describe a translation for translations using vectors and vector sums, and using vectors to find images. You will end by reviewing a real-world problem. If you'd like me to cover any of these topics in greater detail, please leave your request in the comment section below. Please subscribe to this channel if you find this video to be helpful. Thank you. Okay, let's start off by talking about a couple definitions. A translation or a slide is an isometry that maps all points of a figure the same distance in the same direction. Thus, you can use a vector to describe a translation. A composition of transformations is a combination of two or more transformations. So a composition is a combination of two or more transformations. Okay, objective one, translations using vectors. A translation or a slide is an isometry that maps all points of a figure the same distance in the same directions. Thus, you can use a vector to describe a translation. Using the diagram at the right, a translation described by the ray v prime is a transformation that maps point A to A prime so that the following are true. So you see them over here. We got the v prime right here and the A prime. There's the top ray is the vector they're talking about. We can use that to describe a translation. So if these following are true, A primed, V prime V, so here we're talking about going from A to A prime, V, this right here, is a parallelogram if A, V, and V prime are non-collinear. So if A, V, and V prime are not in the same line, then it's a parallelogram. It creates a parallelogram by doing that shift. You can create that parallelogram. And A primed is equal to V prime, and AV is equal to A prime V prime if A, V, and V prime are collinear. So they're showing you here, they have here's V, from here to wherever it comes out to this arrow out here to V. Okay, so that's this one here. And then you have A to A prime, I'll drop below. A to A prime is right here, but they're on top of each other, right? So what they're saying is that A prime is equal to V prime, and AV, this little distance here, AV is equal to the little distance here. Okay, that's what they're showing you here. So it says A prime equals V prime, and AV is equal to A prime V prime. And that's if A, V, and V prime are collinear. It's just facts you can use in the future as you're going through this. For the coordinate plane, recall that you use an ordered pair x, y for a vector. In this notation, the x represents horizontal changes on the x-axis, so to speak, and y represents the vertical changes from the initial point to the terminal point. So the first x is moving you left and right, and the y is moving you up and down. Okay, positive is up, negative is down, and you know all this. Okay. Okay, example 1, translations using vectors. So it says, find the image t under the translation described by the vector 2, 3. And so 2, 3 is a translation, which means right 2 and up 3. So the image of t under the translation 2, 3 is r. And so you look at it, you see, here's t right here. Right here's t. Okay, t right here. And r is up here. And what does it say to do? It says go right 2 and then go up 3. That's the image. It goes from T to R. Find the vector that describes the translation S to U. To go from S to U, you move left 4 units and down 5 units. Okay, so the translation vector is -4, -5. So to go, we're going to go look at it now. To go from S, here's S, right over here. Maybe I'll change colors. S is right here. I'll use red. Okay, and you want S to U, and U is way down over here, right? So what are we doing? We're going to go down. Well, first it says go. What are we going to go? We're going to go 1, 2, 3, 4 in the negative direction. So that's where we get the -4 from. And then we're going to go down 1, 2, 3, 4, 5 to get, okay? So 1, 2, 3, 4. I'm just going to draw it now. 1, 2, 3, 4, negative and negative 1, 2, 3, 4, and 5. So that describes the translation vector is -4, -5. Okay? Okay, example 1, check your understanding. So refer to the example 1, right? But I brought the picture down so you don't have to go backing up and looking through the slides. So it says in A, it says find the image of Q under the translation described by the vector -4, 4. And then B says find the vector that describes the translation from T to S. So go ahead and give it a try. When you come back, we'll look at it and do it together. Okay, I'm assuming you've done that. So let's find we want to find the image of Q, not the pre-image. Pre is the Q, excuse me. Q is the pre-image. We want the image. So where is Q? Q is way down here, right over here in the bottom right-hand corner. I just marked it blue. And they say, find the image of Q after the translation of the vector -4, 4. So -4 means to left and right, right? So it's negative, so we're going to go left. We're going to go 1, 2, 3, 4 to the left, and then it says 4 positive. Oops, there goes that pencil again. Still haven't figured out what causes that. Still haven't figured that out. I got to work on that. So I had the line gets drawn across here, and then it's up 4. 1, 2, 3, 4. So there we have it. Q, under the translation described by the vector -4, 4, is R. The image of Q is R. Let's find the vector that describes the translation T to S. Well, T is right here. I'm going to go to red. T is right here. And it wants us to go to S, and S is right here. So the first thing we do, we got to get the X number. So that we're going to go, what do we have to do in X? We go 1, 2, 3, 5, 6. So we're going to go 6 right there. Probably the straightest line I've ever drawn. And we're going to go from here, we're going to go up. How many? 1, 2, 3. So 1, 2, 3. So that would be 6, comma 3 would be that translation. So we'd write that 6, comma 3. Okay. And this one up here, we came up with R. R was at, well, that's a different point to say here. So anyways, there you have it. 6, comma 3 is the answer to B. And R was the answer to A. Okay, example 2, writing a rule to describe a translation. Using variables, you can say that the vector A, comma B maps each X, comma Y pair to X plus A, comma Y plus B. So you take your X value and add your A to it, or your Y value and add your B to it. That's the translation, moving X and Y to a new place by the difference of A and B. So symbolically, that says the vector A comma Y yields, mapped here, says that X plus A comma is Y plus B. So write the rule to describe the translation. PQRS yields P prime Q prime R prime S prime. Use P as -1, -2. And its image, P, is -5, -1. Okay? So P is -1, -2, and its image is -5, -1. So in order to do that, we're going to look for calculate the horizontal change, which is you start with your P prime where you're going to end up. That value is right here for X. And you're going to take that negative value. It's negative. It happens to be negative, so it's negative here also, minus the value for the X in the pre-image, which is -1. So it's -5 minus -1, and that equals -4. And then you have the vertical change, which is -1. That's your Y now. If it starts off it ends up -1, starts off -2. So it's -1 minus -2. We're getting the difference equals 1. So there are those two values. So the vector here that we're looking for is -4, 1. So the rule the vector X, Y in translation gives X -4 and Y plus 1. So let's see how that works out. So let's pick a value. Let's pick any one of these points. Let's pick Q. So we're going to start off by picking Q. And here's Q. And we want to map according to this rule. Well, the rule says -4, 1, 2, 3, 4, and plus 1. Plus 1. There we are. It's Q prime. R is whatever R is, it doesn't matter. -1, 2, 3, 1, 2, 3, 4, and 1. So right there is R prime. How about S? S is down here in the bottom. We're going to go 1, 2, 3, -4, and up +1. So every one of these are moving by this rule. Take your X value, subtract 4. Take your Y value, and add 1. Here's P. P is the one we talked about in the beginning. P is -1, 2, 3, 4, and up 1. So we go from P to P prime. Okay? Use the rule X, Y to map X plus 7, Y minus 1 to find the translation image of triangle LMN. Well, this is going to be hard because there's not enough room in here. But we're gonna start off. We're gonna say that you take X, and what are you going to do with N? I think we can pick it. Oh, let's pick N. You won't be able to do all the points. We can do it mathematically, but we can't do it on the graph. I don't want to show it on the graph right now. So if we pick N, it says that we're going to do what? We're going to go. The translation is X plus 7. Let's do L. Sorry. Sorry. So we're going to start over here with L. We're going to go X plus 7. So 1, 2, 3, 4, 5, 6. So L is going to end up over here. And the line from L to N is going to run in this direction off the screen way over here somewhere. Okay. So there's where like N will be over here. So it's going to go from here to here. That's L. And then the Y is -1. -1. So it's going to go down from here down 1. So this is really the point. Here's L. Here is L prime right here. Okay, and it goes like this. So N would be 1, 2, 3, 4, 5. And nowhere because it doesn't go anywhere. Okay, so N is going to go from -1. We're going to go plus 7, 1, 2, 3, 4, 5, 6, 7, and -1. We're going to go down 1. The same. It's just going to end up right here. So this is going to be N primed. Okay, and then you're going to come back down here, for your m value, and your m value is going to translate 1, 2, 3, 4, 5, 6, 7, and it's going to go down 1 right here. So m will be here, n's here. So if you translate this, it's going to look something like that. There's your triangle translated. And that's what the values are. We're going to write them out. It's up here, you're going to have x for L. You're going to have L is going to be -6, -1. So you're going to add 7. So L prime is going to be 1, comma, -2 when we do the math. Because you take the current x value, which is 1, 2, 3, 4, 5, 6, and you're going to add 7 to it. That was -6. So you're going to end up over here at 1. So here's, like we said, it's going to be at 0.1. Here's 0 up here, 1, 1, and -1. So the y value is going to be y, which is -1 right now. And you're going to subtract 1. It'll end up being -2. And we started over here, -2. So we went over here and down -2. So that's the first one. The second one's going to be m prime is going to be 3, comma, -4. And then the last one, n, is going to be equal to, n prime is going to be 6, comma, -2. So there's those values. I didn't ask you to go off and do it on your own because I didn't give you a good spot to draw it on or to think about. Okay, objective 2A, and it's A because there are 2 slides that we're going to look at for objective 2. It's broken into 2 pieces. Translations using matrices or a matrix and vector sums. So you can use matrices to find translations, images of several points at once. To translate a triangle, you need a matrix for the 3 vertices and a matrix that shows the translation vector of the 3 for 3 times. 3 vertices, each one. Okay? So when you're going to have a matrix that you're going to be adding, is what you're going to do is you're going to add the points of one triangle, the vertices of one triangle, and you're going to change it to the new triangle position by sliding all 3 points at one time. Okay, example 3, using matrices to find images. So here's this picture we have over here on the right. This is the image we're going to move, okay? This is the pre-image. So it says, using matrices to find images of triangle MFH. MFH. It goes from M down to F and then up to H in the upper right-hand corner. Under the translation 4, -5. Okay, so what that means we're going to do. So here are we've created in the top here, in the gold on the top, we have the matrix that describes the locations of the 3 vertices. So for M, here's M, you see right here, the first one's M right here. We have X is -1 and Y is -1. And if you look over here at the picture, here's 0 right here, or -1, -1 right here. There's our M value, -1, -1, and that's what it is. The top is the X, the bottom is the Y. We're going to be doing matrix math here when we're done, little addition. F is 2, -5. So F is over here. It's +2, 1, 2, and it's -1, 2, 3, 4, 5. So this is 2, comma, -5. And H is going to be, without even looking over there, it's going to be 1, 2, 3, comma, 1, 2. 3, comma, 2. And here it is, 3, 2. Okay? X on the top, Y on the bottom. So what is the translation matrix? The translation matrix, as we said, is every X moves 4 and every Y moves -5. So every X, 1X, 2X, 3X, this is the X for M, the X for F, and the X for H, and the Y values, Y for M, Y for F, and Y for H. So it's 4. We're going to move every vertex 4 positive to the right, all the x's, and all of the y's will be moved negatively 5. So here's the addition. We have our location of our triangle that we're going to image plus the translation matrix, and we're going to add them. So how do you add them? Well, you add them. Each one gets added together and creates a new identical matrix. It's a 3 by 2 matrix. Okay, so we're going to negative 1 plus 4 because it's plus, right here, plus. Negative 1 plus 4 is negative 3. Negative 2 plus 4 is 6. So, I mean, not negative 2. 2 plus 4 is 6. And 3 plus 4 is 7. So look at negative 3, 6, 2 plus 4 is 6, 3 plus 4 is 7. And now we're going to do the y values. You have negative 1 minus 5 gives you negative 6. Here's the negative 6. Negative 5 minus negative, excuse me, negative 5 minus 5, that's plus a negative 5, minus 5 minus 5 is negative 10. And 2, I'll draw that one, I didn't draw it. And then 2 plus negative 5 is negative 3. So this is our new image translation, right? This is the translated image of MFH. This is M primed, F primed, H primed. Those should have been put in there. Okay? And we can't move it on that graph. There's not enough room to move it. But that's the math. To add two matrices, and you get the resulting matrices with the same size, and the positions are all like they all match each other. There's no changing locations or anything like that. Okay? Good. Okay, example 3, check your understanding. So it's your turn to use a matrix to find the image of triangle MFH under the translation 2, 8. So you don't have to probably draw the picture, but if you can do the mathematics, that'd be nice. So I'll wait for you. When you come back, we'll move on. Okay, so now you've had time to do this. So let's see what you came up with. So based on the previous graph, we had the x and y coordinate of negative 1, 2, 3 for the x's, and negative 1, negative 5, and 2 for the y values for the MFH. That's right from the picture. And then we created the translation matrix. We drew this little 3 column, 2 row matrix. And we put in the 2's for the x. We got our x value up here, 2. And we put in 8's right here, all 8's for the y's. The 2's, x's got 2's, the x on top, right? X on the top, y on the bottom, x on top, y on the bottom. So the y's got 8's in the translation. So now we add them together. Negative 1 plus 2 is 1. 2 plus 2 is 4. 3 plus 2 is 5. Now on to the y values. Negative 1 plus 8 is 7. Negative 5 plus 8 is 3. And 2 plus 8 is 10. That's our new matrix. And here's the values. M prime, F prime, and H prime. And this triangle would move accordingly in that translation. But I'm not asking you to draw it. Look at the video again or study this video. Make sure you understand what you're seeing here. Okay, going back to our second slide for objective 2, 2B, I have it written down here as translations using matrix and vector sums. So it says a composition, and we're talking about a composition now. A composition of transformations is a combination of 2 or more transformations. In a composition, each transformation is performed on the image of the preceding transformation. I'll point that out here with this picture. and they're talking about here, in a knight's move on a chessboard, the translation indicated in blue. So you see that's the translation right here, indicated in blue. If I can draw that line, indicated in blue, here it is. That's the translation that we're making. Indicated in blue is the composition of two translations. Indicated in red. I'll change my ink to red. See if we can get that. So there's one translation of, let's say, I don't know which way they're going. We're going to say that the to the right is east, I guess, right? Or to the right. So this is one to the right and two to the left. Or no, and two up, right? Two up. Well, if that's the case, one to the right and two up, and they're saying here that we have two translations. The one translation is the first one. We went from this point, the beginning, to this square. That's the first translation. This was a +2, 0 move, and this one is a 0, +2 move. This is +1, 0. Here, I'll write that in here. 1, 0. And then this one here is going to be a 0, 2. Okay, that's the moves we have here. And the important thing that they said here, in a composition, each transformation is performed on the image of the preceding transformation. So that's why we're showing this. We move, this is one transformation, 1, 0. And then now the next transformation is performed on this spot. So we're going to go 0 from this spot, and we're going to go up 2. Hopefully that's clear. Okay, example 4, real world problem. Tourism. Yolanda Perez is visiting San Francisco. From her hotel near Union Square, she walks 4 blocks east and 4 blocks north to the Wells Fargo History Museum to see a stagecoach and relics of the gold rush. Then she walks 5 blocks west and 3 blocks north to the Cable Car Barn Museum. Now, how many blocks is she from her hotel? Well, that's a good question. Well, the vector 4, 4 represents the walk of 4 blocks east and 4 blocks north. And the vector -5, 3 represents her second walk. So Yolanda's current position is the sum of the vectors 4, 4 plus -5, 3. And those equal, when you add them together, 4 plus -5 is -1, and 4 plus 3 is 7. So the vector -1, 7 is where she currently is. So Yolanda is 1 block west. That negative means she's now west, and 7 blocks north, okay, of her hotel. Okay, example 4, check your understanding. So Yolanda's next walk was to a restaurant 2 blocks east and 4 blocks south of the Cable Car Barn Museum. So how many blocks is she from her hotel? Well, if you remember from the first slide, here's the same picture. She started off right here at her hotel, and she walked 4 blocks east and 4 blocks north. She ended up at the Wells Fargo History Museum, and then she walked 5 blocks, 5 blocks west, and 3 more blocks north, 4, to the Cable Car Museum. Okay, now they're saying she's walking 2 blocks east and 4 blocks south of the Cable Barn Museum. How many blocks is she from the hotel? Go ahead and figure it out, and when you come back, we'll finish it. Okay, well, assuming that you've taken care of that and you've tried it, so what is it? We're going to look at it. Well, she now says that she's up here at the Cable Car Barn Museum, which is right here. Okay, and she walks 2 blocks east, which is 1, 2 to the right. Maybe I'll change colors on that one now. So now she walks 2 blocks to the right, because that's positive, and 4 blocks south, which is negative, right? 1, 2, 3, 4. So now she's down here. This restaurant is right here on California Street, I guess. So now it says, how many blocks is she from the hotel? Well, you could say that she started off at what was it, at negative 1 comma 7, and she added 2 comma, so let me write it down. Negative 1 comma 7 plus 2 comma negative 4, and that equals what? We're going to add them up. We're going to get negative 1 plus 2 is 1 comma 7 minus 4 is 3. So she is now at 1 comma 3. That's 1 block east, 3 blocks north. Let's see if it is. Here's where she started. Here's 1 block east. Oh yeah, there's she at, and 1, 2, 3. She's 3 blocks north, right here. 1 block east, 3 blocks north, and there's the math for it.